All right, welcome back to Algebra 1. Today's date is Monday, January 4th, 2020. We have a few homework assignments tonight that are pretty easy. So 6-1 is just solution inequalities. Our objective today, who wants to read that real quick? Looks like Ripley was first.
Determine if a point is the solution to a system of inequalities algebraically and graphically.
There they are, which means you have two homework assignments, one on the algebra, one on graphical, like on a graphic. So these symbols, you've seen them before with a quiet raised hand. What do we call that symbol on the left? The one that I just circled. Yazzie?
Less than?
Yep, less than. So I'm going to put that right here. Less than.
It's also 21 now.
Oh my gosh, that is right. This is a brand new year, guys. This is not the right date anymore. 2021. Hopefully we'll have a better year. The bar was set nice and low. And then therefore this symbol over here with another quiet raised hand is Haiti.
Greater than.
There it is. Greater than. Okay, well, what is less than or equal to? Is that an alligator chomping on the right or an alligator chomping on the left? And does it have a line underneath? How do you describe that? And you can use your cameras, but I don't know if your camera is reversed or not, so you might be doing it right. You might be doing it wrong from my end. But Giorgio, tell us, what is less than or equal to?
Sorry, I couldn't hear anything. It was like,
oh yeah, how would you describe less than or equal to that symbol?
oh, alligator to the right with a line underneath.
There it is, yep. Less than or equal to, and then I'll do the last one. It's the one that matches the greater than, but equal to as well, so it has a line underneath this symbol. So it's greater than or equal to. Okay, so whenever it's not equal to, notice that you're missing the word equal to on these left two terms. That means that you can't be equal to it. So we have an open dot here. So you have an open point. You can't be equal to, so we leave an empty point. We call this word, by the way, open. These 2 points are open points. The opposite of open is closed. So these are going to be called closed. How would you describe closed points? These are circles that are empty in the inside. How would you describe closed points? Ashley?
They're just filled, I guess.
Yeah, filled. So everyone go ahead and make some closed points, some filled in circles. So the technical term that we're going to say here is that we have closed points and open points. So these are the symbols that we used to use when we were just talking about a number line. So I'm going to come over here and say this is the number line, which we still kind of use for this unit, but more so we are going to be using this next line of notation. So I'm going to call this the coordinate plane. Coordinate plane. So when we have an x-axis and now a y-axis, we're going to use the following. So when I have something that's closed, that means I have just a normal line, and closed also has a normal line. Doesn't matter the direction of the line, just it's a line and it has arrows because it goes on forever and ever in both directions. But how would you describe something that isn't on the line? And the way that we've decided to do that, all mathematicians agree that we should just have a dashed line. So go ahead and make a dashed line here. So this means that on this line, none of the answers on this line are a solution. I'm not allowed to be on that line. Over here, I'm allowed to be on that line because that is a solution. And you can have another line over here. It doesn't matter what direction the line is going, but it's a dashed line. That means it's open. I can't actually be on that point. I can't be on the line. Okay, so this symbol less than means everything to the left. And again, that's coming from the same definition from our number line from our previous, it wasn't last unit, it was unit 4 actually, so it was 2 units ago. Again, this is the number line, the old method, we said, oh, everything to the left of that number, right? So there's a new way to do that now. Instead of saying left, we're really thinking below, less than in terms of the heights. You want to be thinking not left and right because that might mess you up. You want to be thinking in terms of your heights, up or down. Less than means go down. Doesn't mean up. Less than is down. So we're going back to the coordinate plane here. Coordinate plane. Maybe if you don't like those words, you can think number line was just one dimension, coordinate plane is 2 dimensions. Number line was 1 dimension, coordinate plane was 2 dimensions. Those aren't pluses or minuses, they're the graphs that we were using. So if less than used to be left, that means down now. Who can fill in the blanks over here? If I have a greater than, the old system was what? And what is the new system probably going to be called? Who can fill in these blanks here and here on our table of notation? Diego?
Is it right and then up?
Right and up, yeah, exactly. So in unit 4, we said everything to the right of that point. And now we're going to say everything above that line. Perfect. What about these two spots? You've seen them before. They're the same thing. The only difference here is that it was a solid line instead of a dashed line. You can fill in these 2 cells for our table. And don't overthink it. It's nice and easy. It's less than. Less than, does that mean left or right? It's one of those 2. Ripley?
Would it be left?
It is indeed left. And then up or down?
Up?
Not quite. So less than means go
Okay, well,
down. Yeah. Good, good. Yeah, nice. And then finally, I guess I've been using up and above. It doesn't matter. Maybe I'll use the word up because that means the same thing. And then this word up here, it used to be greater than, it used to be right. This table is going to be immensely helpful to you on quizzes, tests, etc. If we are still doing online learning by the time we take our test, then you have open notes for the test. So these notes will be helpful then. All right, so let's try an example. So we have a point. The point is 2, 3. So you can visualize, okay, like if I'm thinking about a coordinate plane, there's my graph, 2 to the right, I go 1, 2, and then I go 3 up, 1, 2, 3. So I'm about right there. You want to be visualizing this in your head. You don't have to write this down. I just want to make sure everyone can picture in their mind, where is 2, 3? There's 2, 3. And I'm asking, is that point a solution to this inequality? And it's just an inequality that you've seen before, except I have 2 variables, an x and a y. So let's plug in our x and our y. Our x is 2, our y is 3, plug in, substitute those points in. So I say, okay, well, it used to be 4x, so now it's going to be 4, well, x is now 2. And I just keep rewriting the rest of the inequality. It's not an equation, by the way. Equation would have an equal to sign. When it's not an equation, it's an inequation or an inequality. Minus 2y, and y over here is 3, so 2 times 3. And if it helps you, you can draw arrows and say that 2, I'm going to do the 2 coming up here, the 2 went into the x, and this 3 went into the y. And then I'm just going to rewrite the rest of the inequality. I'm going to use this symbol greater than or equal to 1. And I do some math and I figure out, is this a true statement or is it not a true statement? I need help though. Can someone help me simplify the left-hand side of this inequality? Yeah, do you go again, please?
You multiply 4 and 2, which you get at 8. Then minus 2 times 3 would be negative 6.
Yep, minus 6.
Is greater than, greater than 1.
And then one more step.
Want me to do it?
Yeah, yes, please.
It's 2. 2 greater
All right,
than
and
1.
then my final question for you, Diego, is 2 greater than or equal to 1, yes or no?
Yes.
Yes, it is. So we can come over here and say yes, or we can say true, which is the more formal way of saying yes. If it's true, then that means that you can include the following. It is a solution. Is a solution. If this was a false statement like 0 is greater than or equal to 1, no, that's not true. 0 isn't greater than 1. 1 is greater than 0. Then you say false, it's not a solution. So right now we're just working with the algebra. Eventually we'll hit example 3 and then we'll see what it looks like on a graph. When you see the graph, it's going to be much, much easier. The algebra, I think, is a little bit harder because you have to do some plugging in some actual math here. All right, you've seen an example. I'm going to give you guys about 30 seconds to try example 2. Good luck. All right, so can someone walk me through this problem, please? Yes, Zeke.
So you would have to plug in your -3 and 7. So you would have 3 parentheses 7 and parentheses minus negative or 4 parentheses and -3 is less than 1 or less than 33. And then
Okay.
after that you would have 21 minus 12 because -4 times -3 would make it positive. 21 minus 12, which is less than 33, which 21 minus 12 would be 9, right?
Like that?
So it would be true.
And 9 is less than 33. Yeah, so that would be true. Except there is a tiny mistake. And I see a few people have already found it by their raised hands. I'll give you first choice on it, though.
So would it be 21 plus 12, not minus?
Yeah. Yeah. You said it too out loud. You said it double negative is a positive, but you still said minus both times. Yeah. Good job. So it's 21 plus 12, which means it's not 9. It is
33.
33.
So it would be false.
Which is still false. Yeah, because they're not, there's no equal to sign, right? So 33 is not less than 33. This is still false. Or this is now false. And false implies not a solution. Not a solution. And I abbreviate solution SOLN. Not even a parentheses here. That's my abbreviation of solution. And I wrote it with terrible handwriting, so you have no idea what I wrote. Let me try writing it again. This is come back pen. Not a SOLN. Is not a solution. All right, so that's kind of like the first half of the lesson, the first homework assignment that you have. How's everyone feeling about example 1 and example 2 with a fist of 5 really quick? 4, 4, 4, 5, 4, 4, 4, 4. Okay. And you guys can use chat too, except it's not really full chat. So I can actually say I'm checking chat. There, I can see chat now. All right. So let's move on to the second half, graphing. So example 3, is -2, 4 a solution on the graph inequality? Okay, well, let's look over here on the right-hand side. I know maybe people haven't copied this down yet, but notice that I have this dashed line, not a solid line. I have a dashed line that goes like down 1, right 1, down 1, right 1, down 1, right 1, and it goes through the points -3, 0. It goes through the point 0, -3. Hopefully you guys can kind of sketch out that graph in your own notes. But the main thing is dashed line, it has a slope of -1, and everything above the line, everything up of the line is shaded. Everything below the line is not shaded. So if I were doing this in my notes, I'd have some sketch that looked like that. No, I don't want to resize you. Come back. I'd have some graph that looked like that, maybe a line that was like right there, and I'd maybe label those points -3, 0, and 0, -3, and then I just kind of graph like that. That would be as simple as you can get for your notes, right? And then graph, where is -2, 4? And it's really important to be precise, especially on your notes. I know sketching isn't super precise, but -2, 4, if I come over here, -2 means left 2 right here, and then go up 4, 1, 2, 3, 4. -2, 4 is this point right here. And again, you can sketch this in your notes and label this. This is -2, 4. Is this a solution? That's the question. And I'll give it to you guys first. Everyone's either going to do a thumbs up or a thumbs down. Does that look like it's a solution? I see some thumbs up, some thumbs down. Because I haven't formally talked about what is a solution yet, so it's okay if you get it wrong. Just guess. Only 2 people have guessed. Come on, guys. Thumbs up, thumbs down. It's that easy. Do you think that this point right here is a solution, just judging off of this graph? All right. More people have voted. So I'll tell you, it is a solution. But why? It's a solution because it is in the shaded region. So before, when we had a one-dimensional graph, we just had a number line. We had maybe an open or a closed point, and we said, okay, everything to the right of that point. That's our shaded region in air quotes. If I'm in this shaded region, if I'm in this line, that means I am a solution. So this is a solution, this is a solution, this is a solution. Anything to the right of that point was a solution. Well, now it's a little bit harder. It's a two-dimensional graph, so I have to have a shaded region. I say anything in that shaded region is a solution. So pick any point. There's an infinite number of points, and that is a solution. Let's try -4, 1. So come up here, -4, 1 is this point right here, -4, 1. Again, make sure that's in your sketch. And then we're gonna do thumbs again. Thumbs up, thumbs down. Is -4, 1 a solution? Thumbs up says, yes, it is a solution. Thumbs down, no, it's not a solution. I should have come back here and said, yes. Because in shaded region, all right, so I see a few people doing thumbs. I see 1 thumbs down, 1 thumbs up. 2 thumbs down, 1 thumbs up. 3 thumbs down, 1 thumbs up. 4, 5 thumbs down, 1 thumbs up. Okay, the majority of you are saying no. Now with a quite raised hand, why? I want to hear from the no's. Why is there a no? Ripley?
Because it's not in the shaded region.
It kind of is. I mean, it's half and half. How do you decide if this point that's on this dashed line is on one side or the other?
I mean, wouldn't it just be majority?
If I draw the point slightly bigger on this side, then I'm going to call it no. There has to be a formal rule for it. And I did talk about this in our table.
Oh, wait, would it be greater than or equal to?
So it's not greater than or equal to because it's not a solid line. So a greater than or equal to is this column right here. That's a solid line. And down here, I have a dashed line. So there's no equal to. What I really have is this. I'm in this column. I'm in a greater than, not equal to, just purely greater than because it's a dashed line. You can all nod your heads. Yes, Mr. Sandell, we agree that's a dashed line. And it's above, it's up from that line. There's the line and everything above that is shaded. So how does that change your answer, Ripley? I mean, you have the right answer. It is not a solution, but why?
Huh. That's confusing.
All right. Someone help him out. I see one hand. I only see Giorgio's hand. Yeah, Giorgio.
Because it can't be equal to, because it doesn't have the line underneath, maybe. Hello.
That's right. Yeah. So if I'm on the line, I can be equal to it. That's what it means, right? I'm equal to, I have a closed point and I have a solid line, but we're not in that realm. We're in this realm where we can't touch that line. Everything on that line is not a solution. So if you're on a dashed line, that is never a solution. If you're on a solid line, that is a solution. So the answer here, we'll say no. And why? Because on a dashed line. And that's the key. If it was a solid line, then the answer would have been yes. But because we have a dashed line, the answer is no. All right. Hopefully that wasn't too confusing. Let's do a quick fist of 5 on example number 3. If I just give you a graph, the trickiest bit is the line. How well will you be able to do these problems in the homework, you think? Most people are putting 4s and 5s. 5s again, another 4, another 4. All right, it seems like you guys are going to get this one. Well, let me crank up the dial of difficulty just a little bit. What happens if I do two lines on a graph? So you can see down here what's about to happen. I'm going to do 2 of these lines, and you're going to tell me if it's an answer. And you're like, wait a sec, 2 lines? How is that going to work? And I will show you. So now I'm going to do a system of inequalities. And again, the word system, again, from our last unit where we had a system of equations, just means 2 or more. And in this case, I'm just going to do 2. When I give you guys your project later, like kind of your test, I will have you do like 7 inequalities. But a system just means 2 or more. Okay, so I have 2 or more. A point is a solution to a system of inequalities if it satisfies, and you guys know this word here, both of the inequalities. You have to work for not one, not the other, but both of them. If you work for both of them, then you give yourself a double thumbs up, pat yourself on the back, we got it. But if it doesn't work for one of them, you fail. You have to work for both of them. So let's try the algebra. So check it out. In example number 4, I have 2 equations. There they are. And I'm testing this point 2, 1. Is 2, 1 going to work for both of those inequalities? So again, it's the same procedure, except you have to do it twice now. Plug in 2, 1. Again, 2 is the x coordinate, 1 is the y coordinate. Plug them in. Can someone help me plug in 2, 1 into our first inequality? I'm going to try to get more people. I know I saw Ripley's hand. I still haven't gotten everyone in here yet. I think Carlos, Braden, Alden, maybe Jose if his internet connection is working. I think I haven't heard from those people. Yeah. One of those 4. Then we have backup for Ripley. All right, Alden, give it a shot.
So you would substitute in the x and the y?
Exactly, yes.
So the x is 2 minus 4 and the y is 1.
And that's greater than -5. There it is. And then can you simplify that for us too, Alden? What is 2 minus 4?
2 minus 4 is minus 2.
Yep, so I'll have -2. Is that greater than -5? That's the question. And you have to ask yourself, all right, -2, think about a number line. There's -2, -1, 0. Okay, and then there's -3, -4, -5. All right, is -2 greater than -5? The answer is yes, it is. Even though it might not look at that at first. -2 is more to the right of -5. Here's -2. It is more to the right of -5. So the answer here is true. I'll just do a T because I'm lazy. That is true. And oh dear gosh, I did not look at the time. It is 8:35. I got 5 minutes. Sorry guys, I'm gonna go ahead and do the rest. I wanted to get more people in here. I'm gonna do substitution for the next one. 5y, well y is 1, so I'm gonna have 5 times 1 Just copying down the less than or equal to, and then I have 6 minus x, so now I have 6 minus 2. All right, I'll simplify this for us. Simplifying 5 times 1, oh, that's easy, that's 5. I'll copy down the less than or equal to, and 6 minus 2 is 4. Is 5 less than or equal to 4? No, 5 is bigger than 4, so that's false. Because this 2, 1 did not work for both of them, the answer is no. No. It has to work for both of them. All right. And then the graphical version is even more fun, even easier, really. I'm going to give you guys just a sec to copy down these graphs. So let me describe what's happening with these graphs. And maybe I can still zoom out so you can see the previous problem. In the first line that I see, this red line, it's a solid line. It's a solid line that goes to the point 0, -2, and it also goes through this point 2, 1. So it looks like it has a slope of 3/2, and it's a solid line. This second line is a dashed line, and it has a slope of -1. It goes through 0, 1, 1, 0, 2, -1. Yeah, that slope of -1, and it is dashed. The other thing that I'm noticing about this graph is, and this, I don't know how well it comes out on your computer, but there's I'm colorblind. I'm going to guess like this is an orangish reddish color over here. There's a bluish purplish color over here. And then up here, it's as if the colors were combined into like a really darker purple color in this kind of V section up here. So the way that you do that when you're taking your own notes is, okay, let me make my axes. I'll have some sort of dashed blue line right there. I'll have some sort of solid line right there. And I'll have like I don't know, a light color over there. And I'll have like a light color over here. And I'll have a really dark color and make this really, really dark up here. Super dark. I'll do hashes in all different directions just to let you know that that is the area that both of those inequalities overlap. That's the darkest section of them all, which means if I am a solution, I have to be in the overlapping region, because this overlapping region is the one that satisfies both above the orange line and above the blue line. Only in this V-shaped region is the solution to both of these inequalities. And then I'll help you graph where's -2, 1. So I'll graph -2, 1 with black, sure. -2, 1 is right here. I'll label that -2, 1. And before I ask you if it's an answer, I'll also graph 2, 1. So +2, 1, this point right here, that's 2, 1. We have a 1.5 minutes left, and I know you guys are kind of scrambling to try to get these notes down right now. This is really important though. So everyone with thumbs up or thumbs down, is this first point -2, 1? Is that a solution to this system of inequalities? Either thumbs up or thumbs down. Everyone take a guess. You've got another 10 seconds to take your guess. The answer here is no, it is not a solution. No. Why? It's not in the darkest region up here. If you're a solution, you have to be a solution to both of them. This solution is a solution to the red one because it's above the red one, but it's not above the blue one. Notice that if you just strictly look at the blue line, it's saying everything up here is a solution, and this is not a solution to that blue equation, so not to both. All right, so, and then the hardest question of this entire thing of notes, 2, 1. Is that a solution? And I told you guys, well, it has to be in this V-shaped region up here, and it kind of is. It's on a point. It's on the line. Is that point a solution? Thumbs up or thumbs down? We got 10 seconds left of class. Come on, guys. Is it a solution? The answer is yes. It is a solution because this is a solid line. Yes. If this was a dashed line, the answer would have been no. But because it is in this region, just barely, and this is a solid line, the answer is yes. If this was a dashed line again, it would have been no. All right, that's all I have for you guys today. I'll zoom back out for the notes.